Welcome back to my YouTube channel, Srinivasu SR Chaganti.
Dear friends, we are going to discuss some problems meant for EAMCET with regard to dynamics.
A body of mass 20 kilograms is at rest. A force of 5 newtons is applied on it. The work done in first second will be.
If the mass of the body is given to be 20 kgs and force applied is 5 newtons, we know that work done W is equal to F into S. Now let's analyze the problem clearly. Here it is given that the mass of the body M and force applied. Work done W is equal to F is. Do we know S here? We don't know. Therefore, it can be understood by using the formula S is equal to UTA plus half AT square. Since the body starts from rest, U is considered to be 0. But F is equal to MA. Therefore, A is equal to F by M. That is equal to 5 by 2 meter per second square. Therefore, S is equal to 1 by 2 into 5 by 2 into 1 square, that is equal to 5 by 4 meters. The work done W is equal to 5 into 5 by 4, that is equal to 25 by 4, 6.25 joules. So what is the work done? 6.25 joules.
A force of 10 newtons is applied on a body for 10 seconds. The change in momentum will be. Force applied is given to be 10 newtons. What is the time of application of force? 10 seconds. We know that rate of change of momentum is force. Therefore, F is equal to mv minus mu by t. 10 is equal to mv minus mu by 10. mv minus mu is 10 into 10 thou is 100 meters per second. A ship of mass 3 into 10 to the power of 7 kilograms initially at rest is pulled by a force of 5 into 10 to the power of 4 newtons through a distance of 3 meters. Assuming that the resistance due to water is negligible, the speed of the ship is. From work energy theorem, work done is converted into kinetic energy. F into S is equal to half mv square. Force F5 into 10 to the power of 4 into S is equal to 1 by 2 into 3 into 10 power 7 into v square. V square is equal to 2 into 5 into 10 power 4 into 3 by 3 into 10 power 7. V square is equal to 1 by 10 square. V is equal to 1 by 10 is equal to 0.1 meters per second. Two blocks of masses 3 kilograms and 1 kilogram are kept in contact with each other on a frictionless horizontal table. If a force of 10 N is applied on the longer block, what is the contact force on larger block? Contact force on larger block is equal to mass of smaller block into force on larger block by total mass. That is equal to 1 into 10 by 1 plus 3. A man standing on the edge of a roof of building of height 20 meters projects a ball of mass 100 grams vertically up with a speed of 10 meters per second and simultaneously throws another ball of same mass vertically downwards with the same speed. The Ks of both the balls are. What is the height of the roof of the building given equals 20 meters? Mass of the ball is given to be 100 grams. What is the speed of the ball? 10 meters per second. It is also given that mass and speed of the second ball are also the same. h1 equals 20 meters. m1 equals 100 grams. v1 equals 10 meter per second. m2 equals 100 grams. v2 equals 10 meter per second. Kinetic energy of the first ball equals 1 by 2 meters 1 volt 1 square equals 1 by 2 into 0.1 into 10 into 10 equals 5 joules. Since the second ball is thrown downwards, potential energy is converted into kinetic energy. Ka or Pa of the second ball equals mgh. That is equal to 0.1 into 10 into 20. That is equal to 20 joules.
Kinetic energy of the first ball is 5 joules and potential energy or kinetic energy of the second ball is 20 joules.
A horizontal force of 500 Newton pull two masses 10 kg and 30 kg are connected by a light string and placed on a frictionless horizontal table. If the force is applied on 30 kg mass, the tension in the string will be. How much force is applied on those blocks? What are the mass of those two blocks? 10 kg and 30 kg. What is the block on which the force is supplied? 30 kg. What do we have to find out here? We have to find out the tension in the string. Acceleration can be found by using the formula F net by m net. That is equal to 500 by 40 equals 12.5 meter per second square. Force acting and tension are in opposite direction. Therefore, 500 minus t equals m into a. 500 minus t equals 30 into 12.5. Therefore, 500 minus T equals 375. Therefore, T equals 125 newtons.
For tension in the string will be 125 newtons.
A box of 20 kilograms starts from rest and slides down an inclined plane 8 meters long and 5 meters high. It is found to move to bottom with a velocity of 7 meters per second. What is the opposing force acting on the box while it is sliding down the included plane?
Here the mass of the box is 25 kgs and starts from rest and slides down an inclined plane of length 8 meters. What is the height of the inclined plane? 5 meters. This is the velocity with which it is sliding down 7 meters per second. This problem can be solved by using the law of conservation of energy. Potential energy at A is equal to kinetic energy at B. In order to find out the force acting on the box while sliding down, F into S is equal to mgh minus half mv square. So F into 8 is equal to 25 into 9.8 into 5 minus 1 by 2 into 25 into 7 square. On simplifying it, we will get F is equal to 76.6 newtons. So what is the force acting on the box while sliding down? 76.6 newtons.
A body of mass 2 kilograms is thrown vertically upwards with a kinetic energy of 490 joules. If the acceleration due to gravity is 9.8 meters per second, the height at which the kinetic energy becomes half of the original value is.
What is the mass of the body given? 2 kilograms. When it is thrown up, how much is the kinetic energy of the body? 490 joules. According to law of conservation of energy, potential energy at the top is equal to 490 joules and kinetic energy becomes equal to 0. But its kinetic energy should be half of the original value. That means half of 490 is equal to 245 joules. Therefore, potential energy U is equal to mgh is equal to 245. For 2 into 9.8 into h is equal to 245. H is equal to 245 by 2 into 9.8. Therefore, the height at which the kinetic energy becomes half is 12.5 meters.
A simple pendulum of mass 200 grams and length 1 meter is turned through 60 degrees and then released. When the pendulum makes an angle of 30 degrees with the mean position, its kinetic energy and velocity will be. We know that F equals K into X. Therefore, K equals F by X. Therefore, K equals M into G by X. Therefore, K equals 1 into 10 by 2 into 10 power minus 2. Therefore, K equals 500 N per meter. Increase in length equals 60 minus 50 equals 10 centimeters equals 0.1 meters. Therefore, U equals 1 by 2 into Kx square. U equals 1 by 2 into 500 into 0.1 times 0.1. U equals 250 into 1 by 100 equals 2.5 joules. We know that F equals K into X. Therefore, K equals F by X. Therefore, K equals M into G by X. Therefore, K equals 1 into 10 by 2 into 10 power minus 2. Therefore, K equals 500 N per meter. Increase in length equals 60 minus 50 equals 10 centimeters equals 0.1 meters. Therefore, U equals 1 by 2 into Kx square. U equals 1 by 2 into 500 into 0.1 times 0.1. U equals 250 into 1 by 100 equals 2.5 joules.
speeds of two identical cars are u and 4u at a specific instant, the ratio of the respective distances at which the cars are stopped from the instant is. Identical cars we mean coefficient of friction is same for both the cars. Let S1 and S2 be the distances travelled by the two cars. Therefore, since the cars are to be stopped at a particular distance, retardation or negative acceleration comes into play. We are using the formula v square is equal to u square plus 2as, but the negative acceleration means minus 2as. Final velocity is 0, therefore 0 is equal to u square minus 2 mu z into s1. s1 is equal to u square by 2 mu z. In the second case, 0 is equal to 4u square minus 2 mu z into s2. For s2 is equal to 16 u square by 2 mu z. Therefore, s1 by s2 is equal to 1 by 16 or 1 is to 16. From a tower of height h, a particle is thrown vertically upwards with a speed u. The time taken by the particle to hit the ground is n times the time taken by it to reach the highest point of the path. The relation between h nu and n is t1 and t2 be the times taken by the particle to hit the ground and reach the maximum height. According to the given problem, t2 is equal to nt1. We know that h is equal to half g2t square minus ut2. By replacing t2 as nt1 in the given relation, simplifying it, we get the relation 2gh is equal to nu square into n minus 2. Next one, a boy can throw a stone up to a maximum height of 10 meters. The maximum horizontal distance that the boy can throw the same stone up to will be. Maximum height up to which the ball can be thrown is small h is equal to u square by 2g. U square is equal to 2gh. U is equal to root 2gh. And simplifying it, u is equal to 2 into 10 into 10, that is equal to 10 root 2 meters. Maximum horizontal distance or range is equal to u square by g. Therefore, maximum horizontal distance r max is equal to 100 into 2 by 10, that is equal to 20 meters. A ball is released from the top of a tower of height h meters. It takes t seconds to reach the ground. What is the position of the ball in t by 3 seconds? The height of the tower from which the ball is dropped, h meters. Time taken by the ball to reach the ground is t seconds. We have to find out the position of the ball when the time is t by 3 seconds. If the ball is dropped from certain height, initial velocity is considered to be 0. Using the formula h is equal to ut plus half gt square, we get h is equal to half gt square, t is equal to root of 2h by g. At time t is equal to t by 3 seconds, h is equal to ut plus half gt square, which can be made use again. Therefore, h is equal to 1 by 2 g into t by 3 whole square. For the sake of convenience, let us consider the height during the time interval t by 3, capital H. H is equal to, on simplifying it, we will get h by 9 meters. For position of the ball from the ground is equal to capital H minus small h, which is equal to h minus h by 9, 8h by 9 meters. A ball whose kinetic energy is E is projected at an angle of 45 degrees to the horizontal. The kinetic energy of the ball at the highest point of its flight will be. When we resolve the velocity component or velocity vector into two components, horizontal and vertical components, vertical component of velocity is considered to be 0 at the highest point. Only horizontal component of velocity comes into play. Ux is equal to u cos theta, since theta is equal to 45. Ux is equal to u cos 45, that is equal to u by root 2. Since we have to find out the kinetic energy at the highest point, let it be some E dash. E dash is equal to 1 by 2 into m ux square, that is equal to 1 by 2 m into u by root 2 whole square, which is equal to 1 by 2 into m into u square by 2, that is equal to e by 2. The minimum force required to start pushing a body up a rough inclined plane is F1, while the minimum force needed to prevent it from sliding down is F2. If the inclined plane makes an angle theta from the horizontal such that tan theta is equal to 2 mu, then the ratio of F1 by F2 is. Here frictional force can be resolved into two cases. F1 is the force when the body is in position to move up, that means frictional force is in downward direction. F1 is equal to mg into sin theta plus mu cos theta. When the body is about to slide down, frictional force is in upward direction. F2 is equal to mg into sin theta minus mu cos theta. When f1 is divided by f2, we will get mg cancel sin theta plus mu cos theta by sin theta minus mu cos theta. And dividing numerator and denominator with cos theta, we will get tan theta plus mu by tan theta minus mu. Since tan theta is given to be equal to 2 mu, tan theta plus mu by tan theta minus mu is equal to 2 mu plus mu by 2 mu minus mu, that is equal to 3. Therefore, the option is D.